have you tried turning it off and on again? It's the oldest cliche in tech support, isn't it?
It's the first thing you ask. And let's be honest, it almost always works.
It does. But the real headache isn't the reboot itself. It's when the server that's frozen is 100 miles away in some locked facility.
That's the friction point. Exactly. You can't drive 2 hours just to flip a switch.
And that's where this thing comes in. The NTI PWR-RMT-RBT-C13.
It's a bit of a mouthful, that model number.
It is. But for about $185, this little black box is basically an autonomous system administrator. We've got the specs here, and the mission today is to figure out how this thing really works.
Right. At its core, it controls power over IP, servers, routers, whatever. But, a lot of smart plugs can do that.
So what's different here?
Well, this unit doesn't just wait for a command. It can actually make its own decision.
And that's the auto ping feature, right? This was my favorite detail.
That's the key. Most admins I know have some script running on another machine to monitor their gear. This bakes that logic directly into the hardware.
So it's watching all by itself.
Constantly. It pings up to 2 IP addresses. And if a device stops responding, if your router locks up or something, the switch handles it.
It just power cycles it automatically.
Yep. Cuts the power, waits a few seconds, brings it back up. No 3.00 AM phone call required. The watchdog is the power strip itself.
That removes a huge point of failure. But I was looking at the specs, and it's doing more than just watching network traffic. It has these 2 digital inputs.
Dry contact sensors, yeah.
So for anyone who isn't deep into electrical engineering, that's just a simple open or closed circuit state, right? It's not processing data. It's just...
That's it. It's binary, which makes it incredibly fast. Let's say you hook up a water sensor in your server room.
Okay, so if a pipe bursts...
Water hits the sensor, the circuit closes, and the NTI unit can immediately cut power to the entire rack.
So it prevents a short circuit before the software tools even know the server's wet.
It's a hardware reflex. And the digital outputs do the reverse. A server crashing could trigger, say, a red strobe light in the hallway.
Now, on the control side, it's not just for clicking buttons in a web browser. It's got a REST API.
An HTTP REST API that returns JSON, which is, crucial for any kind of modern DevOps or automation. You can script it.
You're not stuck with their interface. I love that. The source material also brought up a security application that I thought was really clever.
The physical air gap strategy.
Yes, you can keep a sensitive backup server completely powered down.
And if it has no power, it has no IP signature, it's a cold machine, it's effectively invisible to hackers on the network.
You can't hack what isn't even on. You just wake it up with a switch when you need it.
It massively reduces the attack surface. And you can put this thing just about anywhere.
I saw the temperature rating. It's pretty wild.
It is. It goes from -4 degrees Fahrenheit all the way up to 167.
167. So you're not just limited to a climate-controlled data center. You can throw this in a hot utility closet or an industrial shed.
It's built for those unconditioned spaces. Which, speaking of industrial scale, we have to talk about the cascade feature.
Okay, this is when my mind started racing. The manual says you can daisy chain an unlimited number of these.
Unlimited, in theory. You use the little digital I/O screw terminals to link them together physically.
So you're not managing them over IP anymore. You're physically linking the triggers.
Right. So imagine that one water sensor we talked about.
It trips the first unit.
Which then sends a signal to the next one, which signals the next, and on and on. You could have a ripple effect.
You could shut down an entire infrastructure from a single physical trigger point.
A massive cascading shutdown.
So if we pull back, we started with a $185 box to avoid a long car trip.
But it's so much more. It's a hardware watchdog. It's an environmental monitor. It's a security gatekeeper.
It really does bridge the gap between the digital state of your network and the physical reality of the room. Heat, water, power.
It handles the physics so you can focus on the software.
And that leads me to a final kind of provocative thought. If you can actually cascade an unlimited number of these switches, all triggered by sensors, you aren't just managing power. You're building a decentralized reflex system for your entire infrastructure.
A building with its own nervous system.
Exactly. The building itself could react to a physical threat, shutting down sectors, rebooting systems, way before an OS even logs an error. So the real question is, are we ready for infrastructure that reacts faster than we do?
That is definitely something to think about.
Thanks for listening to this deep dive. Stay curious.